I do want to make sure you guys do understand that in the previous video we talked about how description was just as important as mathematics, but remember physics is a mathematical science. So you're going to have to do math here in this class. Okay, Algebra 1 is sorry, not Algebra 1, but AP Physics 1 is algebra based. So they're not going to make you go too far in depth into all kinds of craziness in terms of math. I'll mention where calculus does kind of come into play, but I'm just going to show it to you. I'll talk about it, but I'm not going to give you how do you guys do the calculus concepts, right? The actual functions that are associated with those concepts. Something to remember is that a person without a physics background already has some vocabulary that describes the motion of an object, right? Anytime you use a word like fast or slow, right? You're describing, the speed of the object. You can talk about its direction, right? You can talk about like, oh, it traveled to the left, right? It went north, or we're traveling north. All right, it's kind of weird. I was just right. It north. Right? You could talk about these compass directions, north, south, east, west. You've used those terms before. You can even use the word quick, right? We define the fourth question as how quick does how fast change. So quick talks about acceleration. Okay? So those are just some like common terms that you've used in your past that focuses on the motion of an object or the description on the motion. But here, what we're going to do in this class, and you can see here in this next bullet point, is that we're going to expand your knowledge, right? We're going to expand your vocabulary to not just be those more non-sciencey technical words, but to get you to those technical words of nature and making those descriptions. Okay. Now, one area where we do have to talk about this a little bit is that every category, each quantity that we talk about here in physics is going to be classified into one or two categories. So the first one is something that we call a scalar quantity. If you just see that, you can kind of see the word scale in here, right? So just think about that. It's a scale, right? And it just like scales up a value, and that's in fact it's kind of what it does in math. Anytime you multiply a scalar by a vector, okay, you're just basically doubling the size, or you're tripling the size. That's the scale you're talking about. And so it does mean. What does it mean here in physics? It does mean number only. Okay, and so let me just turn down that highlighter size a little bit. Sorry, kind of covering up some of the text, right? And so we're talking number only. So some examples of some of the quantities that we're going to talk about. Time is a scalar, right? It doesn't matter if time is positive or negative, or heading in the positive negative direction. Just cares that it's going. Speed, distance, right? These are all, doesn't matter what the direction is, okay? Although distance could be a confusing one, but it's actually just a scalar quantity. And then another one, just kind of get out of this motion world, is mass, right? Mass, there's no such thing as negative mass, okay? Now, on the other side, we have a vector, right? So a vector is a quantity with size and direction. So that means you're going to have a number, right? And this is kind of important. It's going to have a number and a direction, right? So you're going to have to account for both of those when you talk about these values, okay? So various ways a direction can be represented by. One is an arrow, right? So that's a more pictorial representation of a vector. You can have plus or minus, like positive 5 meters per second, minus 5 meters per second. You can talk about it in those compass directions, north, south, east, west. You can just say northeast, northwest, southeast, southwest. Even those weird ones like east, northeast, east, southeast. Those are kind of like your 30s and 60s. So remember, northeast, northwest, southeast, west all cut those north, south, all the planes into halves. Those are 45s. And those weird ones are like east, southeast, east, northeast, south, southeast. Those are your 30s and 60s, okay? And then, so this one here, the plus minus is probably the easiest, right? The north, south, east, west. And then the last one that we're going to see, especially when we do two-dimensional motion, are angles, okay? 30 degrees, 45 degrees. And one thing to note here in physics, make sure your calculator is in degrees, not radians. In fact, physics uses radians as a unit like meters. Okay, so just be aware of that. All right, and some examples. You saw how briefly when we talked about it. We got velocity, we have acceleration. That is still spelled wrong. Sorry. Okay. You have displacement. And we'll give you an example outside of the motion world, but it's actually tied into motion. But forces are also scale or vector quantities. So you just have to pay attention to what the word says, or what the question is asking, is what I should say, and what word do they use. So, for example, if they're talking about if your answer wants a distance, but it looks like they give you all kinds of values that would say, okay, they're actually going to have me calculate displacement. If it says distance, then you only have to report the number. Okay, but if it said displacement, then you have to report the positive or negative sign, or the north, south, east, west. Again, the easy way is positive, negative. And then when we do two-dimensional motion and we focus on forces, we're going to look at a lot of angles. Okay.